let's do 13, which was f of g and g of f and its domain. So let's do f of g of x first, which means we're going to take f and we're going to plug g of x into it. So before we plug in, are there any domain restrictions? Yeah, it's a square root, which means x minus 1 needs to be greater than or equal to 0. X needs to be greater than or equal to 1. So that's my domain so far. It may change as we get to the end, but we'll keep that in mind. So we're going to go ahead and plug in all of, oops, wrong thing, I wanted the highlighter. We're going to plug all of this in to x in f. So we get x minus 1 square root, all squared, plus 1. We get x minus 1 plus 1, or x, which is just a line, so there's no new restrictions. But we do have the original restrictions, so f of g is just x with the domain x greater than or equal to 1. So it's not the entire line, and we're getting restrictions from the function that we're inputting. So domain is just greater than or equal to 1, or if you prefer, interval 1 to infinity. All right, let's try the other version. So now we want to do g of f of x. So we're going to take g and we're going to plug in f of x. We're going to take all of f of x and plug it into g. So far there's no domain restrictions. X squared plus 1 is a polynomial, so it's all real numbers. So no restrictions. It's basically, what are we allowed to do? If you plugged it into a calculator, would you get an error message? No, there's no numbers that would give you an error message. So we're going to go ahead and plug this in to g of x. So we're going to get x squared plus 1 minus 1. And then when we simplify, we'll see if there's any new domain restrictions. So we get the square root of x squared, which is not x, it's the absolute value of x. The definition, this is just a definition. The square root of x squared is defined to be the absolute value of x. Again, there's no restrictions, so the domain is all real numbers. And there we go. So I hope this helps.